Never do minus that. Never. You took option. Oh, no, didn't. Okay. Okay. Let's start with top one. Last question. 1, 2, 3. Cochran is very easy, right? Cochran is the name of a person, you know. Okay. Number 5. Oh, here. Very easy. Never mind. Question? 7. Okay, let's look at number 7. 7 full question, no? Full question. Money. Okay. The movement of electrons in the ball. You must say the movement of the electrons will be repelled to furthest apart, right?
Yeah.
Correct or not? And it will be at the surface of the ball, right? Of the metal dome. Correct? Because it's negatively charged, so that the negatively charged will be equally distributed to the furthest distance possible. Understand? So in other words, if you have a dome, if you have a ball here, let's say, so the charges all will be distributed on the surface. Nothing is inside. Okay? And this one also the same. Distributed to the outer surface of the dome. You say. Is it answer? Discharge ball. Sorry, see wrong. Conducting rod. Or discharge ball. Oh. Okay. The electrons will travel from the metal dome to the metal discharge ball, right? Correct or not? Okay, after that, then from the metal discharge ball, it will be conducting to the conducting rod, right? Electron move to the conducting rod. Then from the conducting rod, it will move to the earth through the wire. Understand? And so you see from here, so the electron will travel from the dome, discharge to the metal discharge ball, then go down here, then go down here, then go to the earth. Is it the answer? Oh, okay. Where's the most number of positive charges on the discharge ball? Where is the most positive number on the discharge ball? Must be here, right? Correct. Okay. Next question.
They say ball becomes charged, but the discharge ball is not charged. It just
It's charged because the electron fly over already.
It just momentarily charged.
Yeah, that is the language issue. At that instant it gets charged. Then later on it will go flow to the earth again.
There is no charge.
Then it's not charged, neutral. Any other question? Number 7, are you okay? Are you okay? Any problem? Number 7, number 8. Cochran is very easy, right? Oh, just call A. Yeah. Charles is sick today. Okay, next question. Number 9. Number 9 you got problem, right? No problem also on number 9. Number 9 no problem. That means within 10 minutes finish whole chapter. Number 9 no problem. Any problem? Do you know how should you connect X and Y? You must connect them parallel, right? Okay. If you have no question, I ask you a question. Okay, tell me, this light bulb dissipate how many watt? This light bulb dissipate how many watt? Count. This one dissipate how many watt? And this one dissipate how many watt? So how much? How many? 50 and 12.5. Any objection? Everyone? 0.5.
The second one, I got 12.5, but I use another method.
Doesn't matter. You tell me final answer first.
25.
12.5. 25.
Another method.
Another method. 12.5. Go for it. 12.5. 25. Okay? The 2% get 25. Huh? Okay, everybody, very simple. This is the answer. This is the answer. Okay? Now, why so? Okay, if you do not know the way, or for whatever reason, just very simple. Convert this to a resistor. Okay? Convert this to a resistor. What's the resistance here? 11.5. 2. Okay? This one also? 11.52, right? Correct. So you can find the I, right? The I square also can, B square over R also can, right? You get this one. What method you get to get it? Which B, which I?
I use 12 multiply I.
Which I? How do you get this one?
50 divided
50 divided by okay. No. Then there's a mistake there. Okay, now, first of all, you need to understand what this means. Can you explain to me what this means? It means if the PD applied is 24 volt, the light bulb will dissipate 50 watt. If, understand? Now what is the PD applied? 12. Understand? So you cannot find the current pass through the light bulb like that. Understand? Because this is under 24 volt, then only can. Alright? So cannot. Okay? Simple, huh? Now number 9, no problem, simple. Number 10, no problem. Number 11, okay, just ask, maybe you ask me that. 12, huh? 12 or, not either. Not either. 12 or, okay. 12 or has some difficulties because you cannot see the North Pole, South Pole, right? Okay. Treat this as North Pole, this as South Pole, okay? Now maybe you can now do again and see.
Then for the change in energy in AC, is it kinetic to electrical?
No. Mechanical electric. Why mechanical? Because things falling down is GPE, then convert to KE. What is mechanical energy? KE and GPE are mechanical energy. Okay, remember I asked you what is mechanical energy? Kinetic energy and potential, gravitational potential energy. So what causes the current to flow through R? Okay, explain. What causes current to flow through R? When the coil rotates, the coil experiencing changing magnetic field lines. Hence, by Faraday's law, EMF is induced. Full stop. Continue. Since it is a complete circuit, induced current flows through R. That's it. Okay.
When I say the cutting of magnetic field,
Actually, opposite also can. What is the function of component Y? Is to ensure that the current reverses every half a revolution when the current passes through the external resistor R. To ensure that the current reverses every half a revolution when passes through the resistor R. Or external resistor R, that's the best. By the way, have you done this one? Have you done this question? Done already. D. D how? Determine the direction of current passing through R. How do we see? Can you tell me A to B or B to A? You can tell me. A to B? Wrong.
because I cannot see how it.
The answer is B to A. You see, I show you once. Now, everybody look here. Now, this one is the rotation, right? Okay, now you can argue like this one, don't know North Pole, South Pole, right? Okay, maybe that one's North Pole, this one South Pole, right? No? Okay, now I want this one North Pole, this one South Pole. Can you prove to me that it's moving from B to A? Try first. No tricky. Try B. You know the evolution of handphone. Initially very big, then become very small. Now big again. I tell you later will be small again. Tell you. Now, so to prevent such a cyclic problem, I will retain this. Now, okay, see now this one very simple. This one is electromagnetic induction. Some students they ask me, very blur in the exam, don't know electromagnetic induction or electromagnetism, left hand or right hand. So the student asked me, can I just remember, see no current, no battery, I use right hand. Like that. So like that is not a very good way to learn, because examiner knows what you are thinking. That's why many students cannot do well, cannot memorize physics. Must understand. Sometimes they give AC generator, or DC generator, AC generator. So they play around the words. Don't try to memorize, must understand. This one is rotate like this. This one must be due to external force, right? So easy, right hand, right? Right hand, So this one is down, magnetic field there. So by right hand rule, the current must flowing out, right? Understand? So when the current flowing out, it will flow to here. Can see it? Okay? And what's the variation of voltage? This one some of you forget again, so I want to revise with you. Tell me, for this one, now, tell me, what happens when the plane of the coil is perpendicular to the magnetic field? Let's say again. When the plane of the coil is perpendicular to the magnetic field, EMF is maximum or zero? Don't have cutting. Is it right to say don't have cutting? The plane, this is the plane, right? This is the coil. So this the coil is like this, right? It's a plane, right? Perpendicular, it will pierce through, right? Pierce through perpendicular, that means it's maximum what? Maximum magnetic field lines that pierce through, right? Still remember that time we have learned magnetic field lines, right? And the time in like this, how the EMF versus time graph? Still remember no? When a coil rotating, the changing of magnetic field lines must be sinusoidal as well, right? So how about the EMF versus time graph? You just need to differentiate, because EMF is the rate of change of magnetic field lines. Rate of change means magnetic field all time is a differentiation. However, today I teach you one more new thing, is the negative differentiation, because by Lenz's law, there will be opposing effect. Okay, so the answer is this sign you differentiate, you get cosine, right? Correct or not? But it's actually negative cosine. So the graph looks like this. This one will go, the zero will touch the maximum, and the zero here will touch the maximum. Maximum here will touch the zero. Go inside, go inside. Understand? Okay, started already. I draw properly later. Later you draw also blur blur. Okay, draw again. So this one is magnetic field lines versus time. Okay, EMF must plot accordingly. Zero become negative, maximum become zero. This one become maximum, this one become zero, maximum. So the graph will be like this. Okay? Okay? Now, what if in the exam they just give you a cosine graph, they never give you a negative cosine graph? Is it correct? It's also correct. Okay, because the negative one is not very important, because negative means direction. Okay, and positive direction, negative, the question never say what. So it doesn't matter if even it's a cosine graph. Okay, so must remember this. Tell me, for this graph to be true, the coil must be like this, horizontal or vertical initially? Horizontal or vertical initially? This is something you don't understand. Hey, you know what I'm talking? Coil. This is a magnetic field. Initially must be vertical or horizontal for this graph to be true. Okay, I want everybody to tell me. Horizontal. Vertical. Horizontal. Vertical. Or 50-50 like that, like play big, small. Oh my god. You still don't understand. Hey, what did I say just now? You forget so fast. When the magnetic field line is maximum, like this or like this? Vertical, right? Magnetic field line is maximum, pierce through vertical, perpendicular. So the plane must be vertical. So is it start from maximum magnetic field lines initially? No, it start from 0. Understand? So must be horizontal. Write down, later you forget it. Okay? This one is crucial.
I don't understand the question.
For this graph to be true, initial state of the plane of the coil, was it vertical or horizontal? The initial state of the plane of the coil, was it horizontal or vertical for this graph to be true?
Or start from 0.
Start from 0. 0 must be
Horizontal.
horizontal.
But if it's maximum, magnetic field line is vertical.
Yeah. Okay. But horizontal means EMF is maximum initially. Okay. So you must not forget the orientation is very important. Exam like to ask. Okay. Now, so in E, how do you say? Which point? PQRS, which one? Q and S, right? Right? Q and S has 0 EMF, so initially it must be in the vertical plane, right? The plane must be perpendicular to the magnetic field lines. All right? Any question? Explain. How to explain? Shashank, explain. They ask you to explain the answer. Why you choose QNS? Because at QNS, the coil experience do not experience any rate of change of magnetic field lines at that particular instant. Hence, EMF induced is 0. I say again, at QNS, the coil does not experience any changing magnetic field lines at that instant. Understand? Because EMF is talking about rate of change of magnetic field lines, right? So when it becomes 0, then you can mention that the rate of change of magnetic field lines is 0 at that instant at Q and S. Okay? Still thinking of this? What's wrong? Okay. Now, how the rotation affects